This is a video in the trigonometry topic of the Pure Maths 1 course, and it covers the sine rule. So the sine rule is used for finding sides and angles of triangles which are not right angled. Sine rule is used when we know two sides, say this one and this one here, and one of the three angles, like that, where the angle is opposite to one of the two sides that we know, so either this one here or this one here down there. We use the sine rule then to find the other side and the other two angles. Or if we know one side, say that one, and two angles, say that one and that one. Of course, if we know two angles, we will also know the third angle, because three angles of a triangle would add up to 180. So the sine rule is used to find all the unknown sides and angles of either of these triangles. So if we take a triangle then, and we label it like this, the vertices, corners, are labelled with capital letters, and they also will represent the angles, the capital letters, and the sides opposite each letter, each angle is labelled with a lowercase letter. So that side is side A, little a, because it's opposite the angle A. This is B, opposite the angle B, and this is C. Now, supposing we draw a line from B to AC, so it cuts the line AC at right angles like that. And we'll let the length of this line, this perpendicular from B to AC, have length H. This then splits our triangle ABC into two right-angled triangles. This one BC to the line, and we've got AB including that line as well. So in a right-angled triangle, we know that the sine of an angle is opposite over the hypotenuse. So in this triangle here on the left, we can say that sine A equals the opposite, which is H, over the hypotenuse, which is C, and also sine on the other right angled triangle, sine C equals the opposite H over the hypotenuse A. The first of these equations here, we can multiply both sides by C, and we get H equals C sine A, and this one is H equals A sine C. So we can see that H is both C sine A and H is A sine C, so we have C sine A then equals A sine C, and if we could divide through by A and C, we can see that sine A over A, divide both sides by A, equals sine C over C. So we have sine A over A equals sine C over C. Now, there was nothing special about drawing the vertical line from B to AC. That was just a line which went from the B perpendicular to AC. Instead, we could draw one from A to BC, like that. And that also cuts the triangle into two right-angled triangles. and we can do the same thing again. And h is now this length here. So we can say that sine b equals h here in this triangle there. The hypotenuse is c, so it's h over c. And sine c equals h over b. So just like before, we can say that h here is c sine b, and h here is b sine c. And so these two must be equal, they're both equal to h. C sine b is equal to b sine c, and dividing through both sides by cb, we have sine b over b equals sine c over c. And so sine a over a equals sine c over c, sine b over b is sine c over c, so all three must be equal, and we have sine a over a equals sine b over b equals sine c over c. So there are three equations there. Sine a over a equals sine b over b. Second, sine b over b equals sine c over c. And thirdly, we have sine a over a equals sine c over c. Also, we can turn this equation upside down and write it a over sine a equals b over sine b equals c over sine c. So the three equations can be written in that form as well. Now we want to use this rule to find the side BC in this triangle here. Here we know the side AB and the two angles A 35 degrees and C 76 degrees. Of course, this means we would know B, because B would be 180 degrees minus 35 minus, which is 69 degrees. Now we want to find the side BC. So the thing to do is to use the equations in the second form here, a over sine a, b over sine b, c over sine c, because the unknown is a length, and the length, the unknown, is on the top of the fraction, the numerator of the fraction. When you want to find an angle, then it's better or simpler to use the first form of the equations, where the unknown, the angle, is in the numerator, the top of the fraction. But in this case, we'll use the second one. So we have a over sine a. Well, in this case, we want to find a, which is BC. So we'll have BC over sine